So this is the cache emulator, and we have over here 6 classes. The main class is the architecture.java, which will do everything and will invoke methods that will do operations on cache and memory. So basically we are taking the response from the user and doing the read and write operations and doing the exit. Moving on to global class. Global class is not much, but all the global variables and methods that do not specify any kind of module are placed in this particular class, and it will calculate and show the read and the write hit and miss counts. Cache class is the main cache body, and it consists of cache lines and does all the operation that is necessary on the cache, such as is cache hit, load from memory, and write to cache. The next class is cache lines. Cache lines is basically a particular line in the cache which will have a set, a tag, a valid bit, and the data. Data is obviously 16-bit. Over here 16 bytes, sorry. And the respective methods which will be invoked for any kind of operations on cache lines. And this is the initialization part of the cache lines. Similarly, we have a memory. Though memory, we have only one 2D array, which is initialized over here and then printed over here. And get memory is obviously gets the data at a particular memory line. So let's go ahead and run it. So I'm already in the folder where my jar file is. You have to navigate to that folder particularly. So over here I will put my command java -jar computer architecture 1.jar. So when I run it, it will ask me enter the associativity from 1 to 8. Obviously, since we have only 8 cache lines, it's user specific, so I don't have any checks for that. So we will go. So here it says cache sets are 4 and shows the initialization, and now asks for the thing. So first we're gonna do read from memory, and we enter the block number as in the example 3 and offset whatever. So here we see a read miss is calculated since the data was not in the cache, and now it has been put into the cache after the read miss. So if we try to do another read for the same block with some different offset, it's gonna be a read hit since we already had that particular value in the cache. Now moving forward, now let's say we give the block number 5 and offset as 1. Here we see the cache is now filled with 5 and the read miss is recorded. Now we're gonna do a write operation. So we go choose the block number 4, enter the offset, let's say I want to add 4, okay, and the new value will be 777, and go ahead. So over here we recorded a write miss because it wasn't there in the cache, so the memory was changed. Over here we can see the offset 4 in the memory block 4 has been changed. Now let's put it back in the memory. So read it and we put block 4. Now it is loaded over here, and as you can see the data has the changed memory value. Let's do the write again to the same block and a different offset probably. The value will be 1, 2, 3. So over here, as you see, the value over here has been changed because it was a write hit, and due to the write through policy it is changed over here as well and in the cache. And let's try an example where both the cache lines of a set are filled. So I entered the choice 1, reading block number 9, which will go in set 1. So that's true. So we have two sets filled up. Now we want to do another. So basically we choose 13 and we give the offset 1 and go for it. So there was a random operation that did that. It's not particularly that the first line is changed. It's a random operation. If we want to try this one more time, read block number 5, 1. See, it was changed. And our records are being maintained over here in the methods, and that was it. And thank you so much. So we're gonna quit this program and go ahead. Existing system. Thanks.